So we're going to look at question 3 now, which is a curve sketching question. And with this curve sketching question, we're asked to identify any asymptotes, critical points, or points of inflection. And here with the critical points, I like to start with critical values, and with points of inflection, I like to start with the location of potential points of inflection. Now here, notice they don't ask where it's positive, where it's negative, where the roots are, where it's increasing, where it's decreasing. They're just looking for the critical points, points of inflection, asymptotes, and a general sketch. However, with a general sketch, we'd like to know increasing, decreasing, positive, negative. All those details come with the sketch itself. We just specifically want you to identify the asymptotes. So looking at the original function, we have f of x equals x over 1 minus x, 1 plus x. Okay. The reason I express it this way is it's super easy to figure out where the roots of the numerator and the denominator are. The roots of the numerator, or the roots, are x equals 0, and the potential asymptotes are x equals 1 and minus 1. Now, these are my potential vertical asymptotes. And to understand if they're vertical asymptotes or not, we're going to take the limit as x approaches minus 1, but we're going to do the directional limits. We're going to start with minus 1 of f of x, the limit as x approaches minus 1 from the positive of f of x, the limit as x approaches 1 from the negative of f of x, and the limit as x approaches 1 from the positive of f of x. And for each of these, if we plug the number in, we're going to get minus 1 over 0, minus 1 over 0, 1 over 0, and 1 over 0. So the question is where these are going to be plus or minus infinity. Which is it? To understand this, I'm going to do a quick sign chart using minus 1, 0, and 1 for my original function, with x, 1 minus x, and 1 plus x. For x and positive, negative, change at 0. 1 minus x, I'm minus positive, change at 1. And for 1 plus x, I'm positive, negative, change at minus 1. Completing the sign chart, we see that we're negative, positive, negative, positive. Okay. So this is going to be, because I'm coming from the negative 1 from the negative side, I'm positive, it's going to be positive infinity. Here, I'm going negative 1 from the negative side, it's going to go off to negative infinity. Here, I'm going to 1 from the negative side. 1 from the negative side is going to be positive. So positive infinity. And 1 from the positive side, with it being negative, it's going to go to negative infinity. Thus, or as the directional limits are unbounded, we have an asymptote, or a vertical, have a vertical asymptote at x equals minus 1 and x equals 1. So that gives us our vertical asymptotes. Now for our horizontal asymptotes. For our horizontal asymptotes we consider the end behaviors. The limit as h approaches infinity of x over 1 minus x squared equals the limit as x approaches infinity, it's an x, of 1 over x squared over 1 over x squared minus 1, which equals 0 over 0 minus 1, which equals 0 over minus 1, which equals 0. And the limit as x approaches minus infinity of x over 1 minus x squared equals the limit as x approaches minus infinity of, this is 1 over x to the 1, so 1 over x, or 1 over x squared minus 1, which equals 0 over 0 minus 1, which equals 0. As the end, or we can simply say, thus, there is a horizontal asymptote at y equals 0. So the end behaviors in both directions is 0. Okay? And I'm going to insert some space here so that we can carry on our discussion a little bit longer. Okay. So now I want to look at the critical points. So in order to look at the critical points, I want to look at f prime of x. In order to compute f prime of x, I'm going to take the derivative. Okay. Now, derivative, we have chain rule. So it's 1 times 1 minus x squared minus x times 2 negative 2x all over 1 minus x squared, which equals 1 plus x squared over 1 minus x squared. Now, f prime of x never equals 0, as x squared plus 1 is greater than 0 for all x. And f prime of x is undefined for x equaling 1 and x equaling minus 1, as neither of these values are within the domain. There is no critical points. So we have no critical points. Now, we'd still like to create a curve sketch. So I'd still like to know where the function is increasing and where the function is decreasing. So to solve this, I'm going to create a quick sign chart about this expression. I have minus 1 and 1, and I have 1 plus x squared, 1 minus x all squared, and 1 plus x all squared. Turns out each of these are going to be positive everywhere. This means that the function is increasing, 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 which is quite interesting. Lastly, we're going to look at the second derivative to determine if there's points of inflection, and if so,